So now looking at 46, it says, which type of transformation can be used to obtain the graph g of x is equal to 4 and 2, which should be to the power of x, from the graph of f of x equals 2 to the power of x. So 2 to the power of x, if you remember from an earlier question, is our parent function, which looks like this. So if we add a 4 to that 2 to the power of x, as you can see, it got a little bit skinnier. So what happened there was that it stretched a little bit. So we can eliminate g and h because those are shifts. We didn't move anywhere. All we did was shrink the graph a little. But if you notice, vertical shrink, that's not actually a thing, right? It's either a vertical stretch or a vertical compress, or a vertical or a horizontal stretch or a horizontal compress. In this case, we are stretching because the graph is getting a little bit skinnier. Therefore, our answer is J. Let's go ahead and look at this. Now we have two parts of a function, and it's asking us for the greatest value of in the domain of the function. So when we're talking about domain, we're talking about the x values. So we want to look at the farthest left versus the farthest right. So what is the greatest value in the domain of the x? We're looking for the greatest value. So what is the greatest, meaning the furthest right? Our answer is 6. Finally, we're looking at number 48. Now with number 48, our parent function is here. Now we moved our vertex 1 time to the left and 4 times up. Now remember that since we're moving to the left, it's going to be inside the parentheses and it's going to be positive. So we move 1 time to the left and we move up 4 times. So x plus 1 has to be plus 4. Now the next thing that changes is that the graph is now facing down. So to be able to make it face down, we are going to put a negative at the front of the parentheses. So based on that, our answer would be F.